Turn your book page to 392. Lesson 3, Pythagorean relationship. Let's look at the key ideas. The hypotenuse is the longest side of a right triangle. It is found opposite the right angle. The sum of the squares of the legs of a right triangle equals the square of the hypotenuse. Let's look at the top of page 392. As you know, a right triangle has one right angle. The side directly across from the right angle, called the hypotenuse, is the longest side of the right triangle. The remaining sides, the rays of the right angle, are the legs of the triangle. Thousands of years ago, people found a special relationship called the Pythagorean relationship among the sides of a right triangle. You can use this relationship to find the measure of any side of the right triangle if the other two side measures are known. Pythagorean relationship states, and we're going to get a whiteboard and illustrate this. So the Pythagorean theorem states that a squared plus b squared equals c squared. A and b are the legs, and c is the hypotenuse of a right triangle. And they illustrate it in your book for you, so here they show it like so. Your right angle is here, and then they told you that opposite the right angle is the hypotenuse, which is the longest side. That's what they're talking about right there. Let's go to the next paragraph. In other words, the square of the hypotenuse is equal to the sum of the squares of the two legs of the right triangle. And in example 1, as we just illustrated, the right angle and the opposite of it is the hypotenuse. Let's look at example 1. What is the length of the hypotenuse of the right triangle shown in the diagram? So what they're showing you in the book is, if we know A and B, we can solve for C. So it says, number 1, the lengths of the legs are 3 feet and 4 feet. Let one leg equal A and the other equal B. So let's do that. 3 squared plus 4 squared equals c squared. So 3 times 3 is 9. That's where they're getting it from. Plus 4 times 4 is 16. Equals c squared. So we're solving for what? Solving for c. 16 plus 9 equals 25. And bring down c squared. So show the 25 in square root, because it says equal to c squared. So we're going to show it as a square root. 25 equals C. So the square root of 25 is 5. 5 times 5 is 25, so the square root is 5. And when we're saying square root, we're saying a number times itself, right? So what would be the square root of 64, just as an example? Well, the square root of 64 would be a number times itself, which is equal to what? 8. Because 8 times 8 is 64. Okay, so the length of the hypotenuse in the problem in the book we know is 5. 5 equals C. Okay, let's continue. So the Pythagorean relationship can also be used to solve the length of a leg. Let's look at example 2. If John places a 13-foot ladder 3 feet from the base of a wall, how far up the wall will the ladder reach to the nearest tenth of a foot? The wall, ground, and ladder form a right triangle. The hypotenuse is 13 feet in length. One leg is 3 feet. You need to find the length of the leg. So if you're looking at this problem at the bottom of page 392, we know that's the hypotenuse, the 13 feet, because it's the opposite side of the right triangle. See, remember, they have the building, like so. Let's just say that's the building. We can see that. The blocks. And he put a ladder up just to make it look like bricks. See? That's the building with the bricks, right? And then he put a ladder up against it. So the ladder looks like so. Right? I'm just freehand, not an artist, right? So we see this. Now, right here, that's the base. Well, let's bring it down a little bit, okay? And so let's say, there we are. That's the base. Right here, you can see the right angle. Boom, 90-degree angle. So we know this 13 feet here is the hypotenuse because it's opposite the right triangle. And then they gave us the base is 3 feet. So we know we're looking for another leg. We already have the hypotenuse. Okay, so let's work this out. We have a squared plus b squared equals c. And we're going to get a clean board in just a second. So 3 squared plus b squared, because we don't know what b is yet. But we know it equals what? 13 squared, because that's what we have for the ladder. Let's plug it in here. We'll do it right next to it. So a squared is what? That's one of the legs. We're going to use 3 squared. We do not have a value for b, the other leg. So we're just going to put it as, just like they have it in your book, we're just going to put it as b squared. However, they gave us the hypotenuse, 13. So let's write it as 13 squared. We're just illustrating it to show you how they came up with this. All right? Now, so they want to know how far will the wall, how far up the wall will the ladder reach to the nearest tenth of a foot. So when we go 3 squared plus b squared get 13, 3 times 3 is 9. That's where they're getting it from. Plus b squared equals what? 13 squared. because they gave that to us in the problem. 9 plus b equals 13 squared. So 13 times 13 is what? 169. So you can bring this down. 9 plus b squared equals 169. Now, what they're doing here in your book is we're solving for b, so we have to get rid of this 9. So we're going to do that with a minus 9 here, and that cancels out this one, and it leaves what? B squared over here. But remember, what we do to one side, we have to do the opposite side, so we have to do a minus 9 over here, right? And so that'll leave us b squared on one side and 160 on the opposite side. And then you're going to show the b squared, because it's telling you b squared equals 160. So b, whatever the value of b, is equal to what? The square root of 160. And so what is that number that equals 160, the square root of 160? Well, you put it in your calculator and hit the square root symbol, and it's going to give you, it'll give you an approximate value. So that's what you see there. B, approximate value, 12.6. That's what the squiggly equal signs mean. It means it's an approximate value. So we have an answer here, 12, the approximate value, 12.6, right? And so we know that when they put the ladder, it will reach as far up the wall. That's what they're asking. See, that ladder is leaning, but it'll reach up to about 12.6 when you lean it against the building. Now look at the note at the bottom of page 392. Most of the time, you will need to use your calculator for the final step when using the Pythagorean relationship. To find the square root of 160 on the TI-30XS multiview, press the second key, then the square root key, 160, and enter. And use the arrow keys to convert the result from a radical to a decimal format. Now I put it in my calculator that I have, and it is an approximate value because that 0.6, the definite keeps running infinite, 12.64, and so on and so on. Okay, so that's the, well, no, I was going to say that's the end, but we have a little bit more at the top. If you're looking in your book, look at the top of page 393, and it gives you a couple notes. Some right triangles display special proportions, which are worth memorizing. A right triangle whose angles are 45 degrees, and 90 degrees displays the following relationship. Leg, hypotenuse, which equals x square root 2. A right triangle whose angles are 30 degrees, 60 degrees, and 90 degrees displays the following relationship. Leg, hypotenuse, which equals what? X square root of 3, 2x. So you can see each one of these triangles they're expressing does equal 180 degrees, but in different ways because of the angles, right? Okay, so we're going to, and I guess that was worth noting, and so they did in your book, so we mentioned it here. But we're going to stop and end this lesson here.